Welcome back, everyone, to another deep dive.
Excited to be here.
This time, we're aiming for the moon.
Cool.
Yeah, but, not just reaching it. This is about how we get there.
Okay.
NASA's Lunar Trailblazer mission. That's our target.
I've heard about this.
It's all about cleverness and efficiency.
Sounds right up our alley.
We've got a fresh article from JPL.
Oh, nice.
February 25th this year.
Hot off the press.
All about this little spacecraft.
Still.
Yeah. So get this. It uses gravity as fuel.
Whoa! Gravity powered. Now I'm intrigued.
Right. So what's Lunar Trailblazer actually trying to do? What's the big goal?
Well, they want to map water on the moon.
Okay, that makes sense. I mean, water is like the holy grail of space exploration, isn't it?
It is, but it's not just about finding it. It's about understanding it.
What do you mean?
Well, like what kind of water are we talking about? Is it ice?
Right.
Is it water molecules trapped in minerals?
Okay, yeah.
Or is it something totally different?
I see. So knowing the type of water is crucial for figuring out, if we can actually use it.
Absolutely. And they're not stopping there. This mission is going to analyze how that water moves and changes.
So like a lunar water cycle.
Yeah, exactly.
But I mean, the moon doesn't have weather like we do.
Right. No rain clouds or anything.
So how does a water cycle even work on the moon?
Well, it's different for sure. No rain or snow, obviously.
Right.
But there are still processes that affect how the water is spread out and changes state.
Fascinating. Okay, but before we get too deep into that, let's talk about the spacecraft itself. It's pretty small, right? Like, I heard it's about the size of a dishwasher.
Yeah, you've heard right. Pretty compact.
And things going to the moon.
It is. It's hitching a ride on a SpaceX Falcon 9.
Okay.
Part of the IM-2 mission.
IM-2. Got it.
Launching no earlier than February 26th.
Okay.
From Kennedy Space Center.
So it's launching soon. But hold on. It doesn't just shoot straight to the moon, does it?
Nope. Remember the gravity is fuel thing?
Oh, right.
It takes the scenic route, a much more roundabout way.
Okay, I'm all ears. Tell me about this gravity-powered trip.
It's called a low-energy transfer.
Okay, so break that down for us. Low-energy transfer, gravity. How does it all work?
Imagine like a cosmic game of billiards,
Okay, I'm with you.
But instead of hitting the ball, we're using gravity to redirect the spacecraft.
Oh, I see. So instead of big engines and tons of fuel,
yeah,
we're using gravity to sort of slingshot Trailblazer towards the moon.
You got it. Really clever way to save fuel.
And probably a lot cheaper, too.
Exactly. But it does require patience.
Oh, I bet. How long are we talking?
The journey. It's going to be 4 to 7 months.
Wow. That's a while.
Yeah. And the funny thing is, the launch date actually affects how long it takes.
Really? Why is that?
Well, it all depends on where the Earth and Moon are in their orbits, you see.
Right.
Some alignments are just more favorable for this gravity assist.
So it's not just about launching, it's about launching at the right time to take advantage of this, cosmic dance, I guess.
Exactly. It's a carefully choreographed series of flybys and thruster bursts.
Okay.
Trailblazer will loop around Earth, get a little gravitational boost from the moon.
Got it.
Even harness the sun's gravity to fine-tune its path.
So it's not a straight shot at all. It's more like, I don't know, a carefully calculated cosmic ballet.
That's one way to put it.
And all of this just to get this little dishwasher-sized spacecraft to the moon.
All to save fuel and maximize the science.
Incredible. And this orbit changing, it doesn't happen overnight, I imagine.
No, it's gradual.
No.
Over time, these maneuvers they'll transform the orbit.
Okay.
From a highly elliptical path, kind of like a stretched out oval,
Right.
to a more circular orbit around the moon.
So it's like gradually getting pulled in by the moon's gravity until it settles into a stable orbit, about 60 miles above the surface?
You got it. And that's when the real fun begins.
The science.
Yep. But before we get to that, just think about it for a second. Using gravity itself as fuel,
yes.
It really is. It's pure physics, but it's leading to these breakthroughs in space exploration.
It's mind-blowing. Okay, so we've got this fuel-efficient spacecraft, but I have to ask, does that mean they had to skimp on the science? Did they have to sacrifice instruments to make this gravity-powered trip possible?
Not at all.
Great.
One of the most impressive things about Trailblazer is how much they managed to pack in.
Okay, so tell me, what kind of scientific instruments are hitching a ride on this gravity-powered mission?
So there are two main ones. The High-Resolution Volatiles and Minerals Moon Mapper, or HVM3.
HVM3. Oh.
And then there's the Lunar Thermal Mapper.
Okay.
That one's LTM.
LTM. All right. So what do they actually do?
Well, HVM3, it's like a super sensitive prism.
Okay.
It analyzes light reflected from the moon,
Right.
and by breaking down that light, it can tell us what the surface is made of.
Ah, I see. So it's not just taking pictures. It's analyzing the light to see what molecules are there, including water.
Exactly.
That's pretty cool.
Yeah.
And what about LTM?
That one's all about temperature.
Okay.
It measures the temperature of the lunar surface.
So it's like a heat-seeking detective.
Yeah, kind of.
Looking for those cold spots where ice might be hiding.
You got it.
So we got this tiny spacecraft, right?
Yeah.
Packed with these high-tech instruments.
Right.
It reaches its lunar orbit. Does it just like park itself and start taking pictures?
It's actually a lot more dynamic than that.
Okay.
It's going to complete 12 orbits around the moon every day.
12 orbits every day.
Yeah.
Why so many?
Well, the goal is to see how lunar water changes over time, right? So as the moon rotates, different areas are exposed to sunlight.
Okay.
Which affects the temperature and, you guessed it, how the water behaves.
So by orbiting so much, Trailblazer can track how those water patterns shift as different parts of the moon get sunlight. It's like a time lapse of the lunar water cycle.
Exactly.
That's amazing. Now remember those permanently shadowed craters at the South Pole, the ones that are supposed to have tons of ice.
I do.
Is Trailblazer going to be able to look into those?
It's going to try.
But I thought they were, permanently shadowed.
They are, but the instruments, especially the LTM, they're sensitive enough to pick up subtle heat signatures.
Even in those really cold, dark places.
Even there. It might be able to tell us if there's ice.
Okay, seriously, this mission is blowing my mind.
Yeah.
A tiny spacecraft orbiting like crazy, mapping the water, peering into the darkness.
It's pretty remarkable, right?
Totally. Okay, so last question before we move on. All this data, where does it go? Who gets to see it?
So it's transmitted back to Earth through NASA's Deep Space Network. You know, those giant antennas.
Right.
And from there, it goes to a brand new operations center.
Oh, wow. Where is that?
Caltech's IPAC.
IPAC, okay.
In Pasadena, California.
Pasadena. So Pasadena is becoming like mission control for lunar water.
It kind of is.
So cool. And who's actually going to work with all this data?
Well, NASA scientists, of course. But here's the cool part. Students from Caltech and Pasadena City College are going to be involved, too.
Wow. Talk about inspiring the next generation. That's fantastic. Okay, but you mentioned something earlier about risk.
I did.
Lunar Trailblazer is part of NASA's SimpleX program, right?
That's right.
Can you remind me what that means and what it means for a mission like this?
So SimpleX stands for Small Innovative Missions for Planetary Exploration.
Small Innovative Missions for Planetary Exploration.
Okay. It's all about doing more with less.
Right.
These missions are designed to be low cost, which allows NASA to take on more risk.
So they can be a bit more daring with the technology and the approach.
Yeah. It's kind of a test bed for new ideas.
Okay. So while there's a chance things might not go exactly as planned,
there's always that chance in space.
The potential payoff, the discoveries, the technology, it could be huge.
Exactly.
That's pretty exciting. It's like a high stakes gamble, but with incredible rewards.
That's one way to put it. And even if a SimpleX mission doesn't completely succeed, we still learn a lot.
Right. Those lessons are valuable for future missions.
Absolutely.
Okay, we've covered a lot of ground here. But I'm sure our listeners are eager to hear about the potential discoveries. What are some of the key things we might learn from all this data?
I think we're about to enter a whole new era of understanding the moon.
Really?
Yeah, I think so.
Tell me more.
Well, for starters, we're going to get this really detailed picture of how water is distributed on the moon. And remember, it's not just about where it is, but also what form it takes.
Right. Ice-absorbed molecules, maybe even something we haven't thought of.
Exactly. And we'll be able to see how those deposits change over time.
So it's a dynamic understanding, not just a static snapshot.
Precisely.
Okay. But could this knowledge, could it help us understand water on other celestial bodies too?
Absolutely.
How so?
Think of the moon as a natural laboratory.
Okay.
A laboratory for studying airless bodies.
Oh, I see.
So By figuring out how water behaves on the moon, we can get insights into what might be happening on other moons, asteroids, maybe even planets.
So the moon is like a key to understanding water throughout the solar system.
It is.
That's amazing. And those permanently shadowed craters, the ones with the potential ice deposits, what about those?
Oh, those are incredibly exciting.
Right.
Those craters have been shielded from sunlight for billions of years.
Wow. Creating these incredibly cold traps.
Yeah.
Where water ice could have been building up for eons.
Imagine if we confirm that there are significant ice deposits there.
It would be a game changer.
Right. We've talked about how water is crucial for life support, for fuel production, even radiation shielding.
It's true. And having easily accessible water on the moon would make building a lunar base much more feasible.
So we're not just talking about, short visits anymore. We're talking about a sustained human presence on the moon.
Exactly. It would be a huge step forward.
Okay, I think we've covered a lot for this first segment.
We have. There's so much more to unpack.
There is.
But we'll have to save that for next time.
All right. Stay tuned, everyone, because in the next part of our deep dive, we'll delve even deeper into those potential discoveries and what they mean for the future of lunar exploration. And trust me, you won't want to miss it.
It's going to be good. It really is. You know, it's amazing to think about it.
This mission, I mean, it's small, relatively low cost.
Yeah.
But the impact, understanding the moon.
It's huge. Right.
Huge.
It just shows you sometimes, thinking outside the box.
Yeah.
Taking a risk.
Taking a risk, yeah.
It can lead to breakthroughs.
Totally. And speaking of risks.
Oh, yeah.
We should probably talk about, the challenges.
Okay.
It's not easy sending a spacecraft to the moon.
No. Especially not on a gravity-powered journey, right?
No, not at all. I mean, there are hurdles.
Like what kind of challenges are we talking about?
Well, for one, this low energy transfer,
Wow.
It requires incredible precision.
Oh.
You can't just, point the rocket at the moon and hit the gas.
Right.
It's not like that.
So any tiny miscalculation could send Trailblazer off course.
Could send it way off course.
Wow.
They have to take into account the gravity of everything.
Everything.
The Earth, the moon, even the sun. Making these tiny course corrections, it's
That's a lot of pressure.
It is. It's a balancing act. And then there's the moon itself.
Oh, right.
Not exactly a friendly environment.
No. What the biggest concerns there?
Well, extreme temperatures, for one, swinging wildly from hot to cold.
Yeah, I've heard about that.
Intense radiation from the sun.
Of course.
And the constant threat of, micrometeoroid impacts.
Oh, right. So, I mean, Trailblazer not only has to navigate this crazy gravitational dance, but it also has to, survive out there.
It does. It's a testament to the engineers.
Yeah.
They built this tough little spacecraft.
But like a little warrior.
It is. Going out into the cosmic battlefield.
But even with, the best engineering, there's always that chance, right?
I don't know what.
The unexpected, I mean, space is unpredictable.
Oh, absolutely.
Equipment malfunctions.
Yeah.
Solar flares.
Yeah.
Who knows what else?
You never know what's going to happen out there. That's part of what makes it exciting, though.
That's true. I mean, it's the risk, right?
The risk, yeah.
Pushing the boundaries, exploring the unknown.
Exactly. Venturing beyond what we know.
That's what drives us.
Right, it does. And even if there are setbacks,
yeah,
we learn from them.
Right. Those lessons are crucial for the future.
For sure.
Okay, so talking about the future, what's the timeline here? When can we expect to see some of this data from Trailblazer?
Well, first, it's got to get there, right? 4 to 7 months to reach the moon, get into that science orbit.
Okay, so we have a bit of a wait, but once it's there, instruments are running. How long will it be collecting data?
The plan is at least 2 years.
2 years, wow. That's a lot of data.
It is. Lots to map, lots to learn. Scientists will be busy.
And the students too, right?
Oh, yeah. The students will be right there with them. It's going to be an exciting time for lunar science, that's for sure.
It sounds like it.
Yeah.
I mean, we're really on the cusp of something new here, aren't we?
I think so. A new era of lunar exploration.
And Trailblazer is leading the way.
It is.
Now, let's say, for example, those ice deposits in the South Pole craters.
Yeah.
They're there.
Mm-hmm.
What happens then? What are the possibilities?
Well, if we have readily available water on the moon,
Yeah.
it changes everything.
How so?
Think about it, a permanent lunar base.
Oh, wow.
Not just visiting, but staying there.
That's incredible.
A lunar base.
Yeah.
For science, for resource extraction.
It's like science fiction, but
It's getting closer, right?
closer all the time.
Missions like Trailblazer, they're making it possible.
So it's not just about, will we go back to the moon? It's when and how.
Exactly.
And Trailblazer's helping us answer those questions.
It is, providing the knowledge, the data we need to make those decisions about the future.
It's amazing to think about. This small spacecraft
Yeah.
making such a big impact.
It is.
It's really a testament to innovation, isn't it?
It is, to pushing the boundaries.
Okay, before we get too far ahead of ourselves,
Mhm.
I want to bring it back to you for a second. What are you personally most excited to learn from Trailblazer's data?
Oh, wow. Well, I mean, for me, it's those detailed maps of lunar water.
Yeah.
Seeing how it varies across the surface.
Right.
How topography affects it.
Yeah.
Sunlight, what it tells us about, the moon's history.
So it's not just the water itself, it's what that water can tell us about
About the moon's evolution. Yeah.
billions of years of history.
Billions of years. And of course, I'm really curious about those shadowed craters.
Of course.
What's hiding in there? Clues about the early solar system, maybe even the origin of water on Earth.
Big questions.
Big questions. It's like a cosmic time capsule.
It really is.
Oh,
And who knows? Maybe Trailblazer will find something,
yeah.
something totally unexpected.
Oh, that's always possible.
Something that changes our whole understanding of the moon.
That's what makes exploration so exciting, right?
It is. Okay,
Mhm.
so we can't actually see Trailblazer, right? I mean, not with our eyes.
No. Too
Yeah.
small, too far away.
So how do we follow along? How do we keep up with this mission?
Well, NASA has a great website,
Right?
social media too. They post updates, images,
Okay.
and there are websites and apps that track spacecraft.
Oh, cool. So you can actually see where Trailblazer is.
Yeah, you can follow its trajectory, see what it's doing. It's a great way to stay connected to the mission.
I'll have to check that out.
Yeah.
Okay, before we wrap up this part, I want to go back to the idea of risk and innovation for a second.
Sure.
We talked about SimpleX.
Right.
Low cost, high risk, kind of a proving ground for new ideas.
Mm-hmm.
Can you give us a little more context on the program itself? Like, how does it fit into NASA's overall strategy?
Well, it's about testing new technologies, things that might be too risky or too expensive for those big flagship missions.
So it's a way to push the boundaries without bidding the whole farm, so to speak.
Yeah, exactly. And if a SimpleX mission is successful,
Yeah.
then those technologies, they can be used in bigger missions later on.
So it's like a stepping stone,
Yeah,
making those risks to move the whole field forward.
that's the idea.
And even if it doesn't totally succeed, the lessons learned are valuable.
Oh, absolutely. You learn from everything.
Failure is just part of the process, right?
It's part of the process. It's how we get better.
It's inspiring, really, seeing how much can be accomplished with a small spacecraft, a clever idea,
Mm-hmm.
and a lot of ingenuity.
It proves that you don't always need, massive rockets and billions of dollars to make incredible discoveries.
Right. Sometimes it's about thinking creatively, working with what you have,
Yeah.
using the laws of physics to your advantage. Well, I think we've covered a lot of ground here in this segment. The challenges, the discoveries, the possibilities.
It's a lot to be excited about, that's for sure.
There is. And I'm sure we'll have even more to discuss as the mission progresses.
Absolutely.
But for now, we'll have to leave it there. Stay tuned, though, because in the next part of our deep dive, we're going to explore the bigger picture. What do Trailblazer's findings mean for, not just the moon, but for our understanding of the universe?
The big picture. I like it.
Welcome back to the deep dive. We've been talking all about Lunar Trailblazer,
Quite a mission, huh?
gravity slingshots,
Mm-hmm.
lunar water maps.
Shadowed craters.
It's been quite a journey. But there's always more to discover, right?
Oh, always. That's what makes space exploration so captivating.
Exactly.
Hmm.
And, we were talking about the bigger implications of this mission.
Yeah.
What really gets you excited about Trailblazer? In the grand scheme of things, I mean.
It's not just about the moon. The data we're going to get,
Yeah.
it could change how we think about water in the whole solar system.
Oh, wow. You mentioned the moon as a kind of laboratory for understanding water on other celestial bodies. Can you talk about that a little more?
Sure. The moon, it's close, relatively speaking.
Yeah.
And we can study it. We have the technology.
Right.
So we analyze how water, how it's created, how it's lost, how it gets trapped on the moon. And it gives us clues about what might be happening elsewhere.
Okay.
On other moons, asteroids, maybe even planets.
So if we can, crack the code of lunar water,
Yeah.
we get a key
exactly.
to understanding water in other parts of the solar system.
Places that are much harder to get to.
Like Mars.
Mars, for example. There's evidence of ice there.
Right.
And moons of Jupiter and Saturn, too.
I've heard about those.
Mm-hmm.
So Lunar Trailblazer is giving us, a piece of a much larger puzzle.
It is. A puzzle about water.
And that puzzle covers the entire solar system.
At least. And maybe even beyond.
What do you mean?
Well, the processes we see on the moon, they might tell us something about water on planets around other stars, exoplanets.
Wow. Okay. So we're talking about a mission that could change our understanding of water.
Yeah.
Not just on a local scale.
No.
But on a cosmic scale.
It's possible. That's what's so exciting. A small mission, but the implications could be huge.
It just shows you sometimes the most important discoveries come from humble beginnings.
It's true. Science is like that. Exploration, discovery.
Always reevaluating what we think we know.
Exactly.
So what would be the most surprising thing Trailblazer could find? The thing that would really, shake up the scientific community?
Oh, that's a tough one. But imagine this.
Yeah.
The data comes back.
Right.
And it shows that the moon's water.
Mm-hmm.
It's different than we expected.
Different how?
Let's say it's from a different source.
A different source.
Not from our solar system.
Extraterrestrial water on the moon.
It would be mind-blowing.
It would. What would that even mean?
Well, it would mean that water, which is, essential for life.
Right.
It might be much more common.
Oh, wow.
Throughout the universe, we thought.
That would change everything. I mean, how did that water get there? What else is the moon hiding?
Exactly. So many questions. It would be a whole new chapter.
A whole new chapter, yeah. And I bet the scientific community would be pretty excited.
Oh, they'd be buzzing, trying to figure it all out.
It would be a pretty amazing time for science.
It would. And it would show just how important missions like Trailblazers are. Missions that, that explore the unknown, challenge what we think we know.
Absolutely. Well, as we wrap up our deep dive into Lunar Trailblazer.
Bittersweet, isn't it?
It is. But thank you so much for sharing your expertise with us.
My pleasure.
And to our listeners, thank you for joining us on this incredible journey.
Thanks, everyone.
We hope you learned a lot about this small but mighty mission. And remember, Lunar Trailblazer is just the beginning.
Just the start.
There's so much more out there.
A whole universe.
Waiting to be explored. Keep looking up, keep asking questions, and never stop exploring.
Keep exploring.